Hello, everyone. Welcome back. So this is the week 6 right now. So we finished review the homework. We were introducing new topic today. Today we were introducing some linear line. So, all right, let's go this one. All right. Everyone come back or not? Please confirm when you was in a class.
Yes.
Okay. At least I heard one.
Yes.
Okay. If you're not here, I didn't say yes, right? All right. So whenever we come back, if you finish drink, just come back. All right. So this week we try to introducing some linear line. Just what we learning before today's class. What you find is you only find one variable in the expression, right? You find something, say 3x in the something x in the equation, x one variable in the inequality, in the compounding inequality, and the inequality with absolute value. You only find one variable in the expression, right? Right. So that would be easy for you right now. I consider that one would be easy part for you right now. So right now in from this class, we're introducing two variables. Give one example. Earlier, when we do the one variable, something like say, when you drive out, you fill your mom, dad go to the gas station, fill gas. So, okay, today I will fill $15 gasoline. And one gallon of the gasoline is $3. So how much gallon you can fill? You can build up a quick equation, say, okay, I have $15, right? So the price of the gasoline is $3 per gallon, right? So how many gallon you can fill? So you can $15 3x gallon, right? So you can find a solution x. I can fill 5 gallons, like that. You only have one variable, right? Right. So you go to the something like I give you and your mom give you $20. You go to the grocery store to buy the apple. So each pound of the apple is $2. $2 per pound, right? So it give you $20. How many pounds you can pay? You can buy. So you can buy. So you get $20. I buy the $2 per pound. You got an X pound. So X, you get 10 pound, right? So you know two of them, you can build the equations. You can build the kinds of equations. So right now we do a little bit more complex situation. So right now I say the gasoline prices we know is $3 per gallon. So we want to know is, all right. So if I fill the 1 gallon, so here is the price. Here is the gallon I filled. All right. This is the price I should pay. All right. So the price is determined. The prices is determined, but the gallons was undetermined. So suppose I want to fill 1 gallon. So you only need to pay $3. You get 2 gallon, you pay $6. You got 3 gallon, you got you need to pay $9. So if you got 0 gallon, of course you pay $0, right? Add here. So you can pay 4 gallon. You want to buy 4 gallon, you pay $12. You pay 10 gallon, you need to pay $30, like that. Right? Continue, move on. So like this. So you can see this is a pattern. There's a kind of pattern here. You give a gallon, you needed to pay relative amount of money. This money was determined, but this one was not determined. This one can be changed. Just like I say, the gallon, you can determine, you based on your car size, right? You can, based on how much money maybe you have, you can say, I only have $30. The maximum you can fill is 10 gallon. Oh, okay. So this is car, actually you filled until they are totally full. you need a 50 gallon, okay, you need to pay $45 like that. So it's not just pay $20. You want $20. You also your 20 gallon, you have to pay $60. So it's not determined by one of them. It's determined by one of the number, right? So if you have $20, you know the prices, you determine the gallon. So if you this kinds of relationship actually have the two available here. Okay, you can determine the money, so you know how much gallon you filled, or you can determine I want to fill how much gallon and pay how much money. So there's some relationship in between, man. So we give them some variable here. All right. So first variable here is x, is right, x here. The other variable will be y here. All right. So have two variables. So y was determined by the prices. So if you don't give the y, I can determine x. If you give x, I can determine y. Right. Right. So like this station. So they have this kinds of relationship. We call them linear relationship. All right. So from now on, we based on these kinds of relationship, we give them a pattern. Something like this is x, this is y. We give them a pair. We call them a pair. This is a pair. All right, a pair. So if you x was determined, you can find out y. They have some relationship inside, like just like the relationship actually is right here. You giving x, you can determine y, or you give y, you can determine x, right? So this is a pair. They have some pattern relationship here. So we write here is 1, 3. All right. Here is 2, 6, and here 3, 9. This is a pair. X, Y, a pair. Earlier, when we do the say x equal 3, how you graph them? You only graphing on these kinds of graphing, linear line, right? So here is 0, here negative infinity, here positive infinity. So 1, 2, 3. 3 is right here. X equal 3. So actually is you got a list start. You only graphing on one line. So if you say x greater than 3, you when graphing is 3, right? This part. And right, view x less than negative 3, you say you graphing like this, right? Right now you have two x, y, and you have a pair, each pair of them. So we graph in different way. We introducing this called x, y coordinated system. They have the two different. They have their own. That like x, you steal from negative infinity to positive infinity, right? I give this is x, but they have another variable. I give their vertical way from negative infinity to positive infinity. So each dot, I can graph out this XY coordinated system. Something like 1 and 3. 1 and 3. So 1 is belongs to x, y belongs to 3, right? So for x, you pick 1. For the y, you pick 3. So they have like this way. They actually is this dot. This dot is 1, 3. This is we put this dot in the x, y. This is y, right? Y is vertical. X is horizontal system. We call XY plane coordinated system. You can any dot. They have a pair. Any dot is not just one number. Like in this one, any dot is one number, right? Something like here is 3. You can find a dot. In this XY coordinated system, at least you need to make of x and y. It's a pair. This is a pair. Need x and y, right? So you can see all these kinds of gallon and dollar. So y means the money you paid. X means how much gallon you filled. All right. So x. So you fill 1 gallon, you pay $3. You pay 2, you got $6. So actually it's right here. to 6. All right. So if you buy 0 gallon, you pay $0. Actually, it's right here. So you can see X. If you pay half gallon, you need to pay $1.5. It's right here. All right. So you can do all these kinds of dot on this XY plate. Something like say 5, you need to get 15, actually somewhat very high here, right? So 5, 15. So if you connect these all dot together, something like this dot, all dot together, actually you can change, you can find they are on the same line. I extend. So you can put all this dot, on this XY system. Here is 0, 0. Here is half, 1.5, and this is 1, 3, 2, 6. Link together. It becomes a linear line. It's a linear line, right? So this one is expressed actually exactly is y equals 3x. So you can see it determines how many gallons you want to fill in your car. You know how much money you will pay. So you can pick any one number. I want to fill 3 gallons. You have to pay $9. Right, is right here. If you pick 3 here, you just do the vertical up, find their cross point. So you can know it's 9, 3 and 9 as well. So this 3 and 9 also on this line. If you fill 4 gallons, you put this up. Finally, I have a cross point here. You can find the data right in the Y Excel. Actually, need to extend it here. So you pay this $12. So if you pick 5, you need to pay $15 extra cross points right here, right? Should be. This is not drawing so accurate, right? Should be on this line as well. All right. So if you say what's the negative number? In reality, yes, the negative number for these cases is not correct. You didn't fill -1. But you from the seller point, you can say I sell you $1, I will get $3. Sell you 1 gallon. Looks like you borrow 1, so you need to pay -$3. So for this typical example, it's not reasonable. But in some reality, they need a negative number. They have some other meaning as well in the negative time. Here is say -1 will be -3, right? So link all these kinds of dots together. You find a linear line, right? All right, so this is the first example. Second example I talked about it right now is the money in Apple. If you pay $20, your mommy give you $20, go to the grocery supermarket to buy an apple, $2 per pound. How many pounds you can get? You get 10 pounds. You can 10 pounds. 10 pounds, right? So, okay, we can also build a similar situation. So this is the pound I want to buy. The apple I want to buy. This is the money I need to pay. So we say this is X pound. We buy X pound. The money is Y dollars. So if you buy 0, you do of course pay nothing, right? You buy 1 pound, you need to pay $2. If you buy 2 pounds, you get $4 need to pay, right? So you got 3, you got $6 in the pound. So their relationship is Y equal to X, right? Y equal to X. Let me use a different color to make sure I can get it a little bit clear when I do graphing. Let me use this one. All right. So Y and X, they have some relationship. So when you put this X and Y into pairs, will be 0, 0, 1, 2, 2, 4, and 3, 6, and even further, right? If you right now say pay by 10 pounds, you need to pay $20. It's be 2, 10, and 20. So each will have a pair. So let me clear this part. Try to redraw graphing here. Let me clear here this part. So when you can put a list dot, take your notebook out and put a list dot in X, Y graphing. How you find out? how you find the dot? So if you say pay by £0, you pay $0. Actually go through here, right? If you buy £1, you pay $2. You pay £2, you gotta pay $4. £3, you got $6. They have the similar kinds of situation. If you link these together, they are in one line. If you link it together, they are in one line, right? One line. In one line. All right. All right. So they have this kinds of situation. So let's see this quick example here as well. So you can see this is a linear line. This is a linear line. Earlier we give the one example, money pay for the gasoline. Well, also they have some of the linear line as well. Actually, the earlier one is past the 1, 3. Let me go back. Earlier graphing is like this way, right? Right here. Earlier is this line. This is the gasoline example. This is Apple example. They have different linear line, right? So you guys can find this situation. When they have this relationship, you can graph it online. So this one is y equals 3x, or this one is y equal 2x. All right, all right. Okay, let me give some more examples. So you can x, y, they have these kinds of relationship. They can graph it into a linear line. You can find any two dots. You can only find two if they are linear line relationship. You can find the two dots. You can make a linear line and extend it. So you can got this linear line, right? All right. So actually, this example we already talked about it. So you can use the pair. You can find the pair. At least you need to find 2 pairs or 3 pairs. You can find at least linear line, right? Right. All right. So let me go do a little bit further one. Let's see more examples. More examples. So suppose there's something, they have some relationship of this one. This example. They have the y and x have this kinds of relationship. Can you guys graphing on this line? Take your notebook to write graphing, use the table. So we can build up like this kinds of table, all right? So x, this is y, right? So they have these kinds of relationship. So if x equals 0, y will be equal 0, right? If x equal 1, y will be equal -4. 2, x equal -8. All right, we find the 3 dots. Let's use the 3 dots first. So 0, 0, this pair is 0, 0, right? 0, 0, this is 1, -4. This is 2, -8. So 0, 0 is right here, x0, y0, right? Exactly this point, right? When x equal 1, y equal -4 is right here. When x equals 2, y equal -8. Let me extend here, 6, 7, 8. So equals 2 will be right here, down here. This is down, it's -8, -6, -7, -8. This is -2, +2, -8. Here is 1, -4. Here is 0, 0. You can find this dot on this coordinate system. Right. So we can link them together. All right. We can graph into a linear line. Right? This linear line. This is also linear line relationship. Okay. Let's see more examples. So you can see graphing is a linear relation. You can, if you do more, definitely they are very close. If you do say -1, here is +4. So -1, +4. I didn't graphing so good, right? Let me clear this one. Let me do one more time. So -1 is +4 is right here. -1, +4, 0, 0 here. So we can link them together. Yeah, this linear line relationship, right? So you can do that. And see the fourth example here. If they have these kinds of relationship, what that means? Something like this one, typical situation, say, some situation actually just say the prices of the, let's give some more examples. Say if you the list day, the prices of this let's talk something toy. Let's say one toy is only need $50, just like 50 cents. If you buy one, you paid 50 cents, $50, right? And today is a promotion. Whenever you buy, doesn't matter you buy or not, I will give you $5 discount. So the money you need to pay actually is the item money, the item of toys you buy, right? And time 50 cents. This is total money you pay, and they give you $5 discount. And so right now is the money you need to pay, right? So they have these kinds of relationship. So we can, what do we need to do here? We can also use these graphing methods, or use XY methods to find out. So if I say, if you want to buy zeros, actually you got a -5. Actually, you pay -5 means you get a $5 whenever you're coming, right? So if you buy one items, you need to pay -1.5. If you buy 10, you only need to pay nothing. It means if you can pick 10 toys out of the store when they are doing these kinds of promotion, right? So if you buy 20, so you only pay $5. Initially, you need to pay $10, but since they have $5, I have the promotion, give you $5 back, so you only pay $5. So you can put it here, 0, -5, right? And 1, you got -4.5, and 10, you got 0, and 20, you got 5. All right. So let's graphing here as well. Let me graphing here. Graphing. So when it's 0, -5, actually it's this point right here, right? This is 0, -5. X 0, Y got -5. Their cross points right here. And when you 1, you got 4.5. 4.5 is right here. When you got 4, let's see, you have, if you pick 4, you pay the -3, right? You can actually get $3. With 4, -3. I'm sorry, here 1, 4.5, I'm wrong for this one. 4.5 actually right here. 4.5 actually is -4.5 is right here. 4.5. Here is 4, -3. This is 4, -3, right? So first dot is right here, second dot is right here, third dot is right here. So we can link these 3 dots together. They are in a linear line. You can graph it into a linear line, right? So you can say this one is half x minus 5. When x got 0, y got a -5, 0, -5, right? So if you x got 4, here became 2, 2 minus 5 got -3, is this dot, right? So you could actually, you can imagine what this dot, when you pay 0, when y get 0, it's 10, right? 10. Because when you put a 10 inside it right here, and you finally just pay $0 out of there. So actually this linear line describe this situation, this linear line situation. All right, let's do some more exercise about this part. Let's see some more examples. Right? So they have some relationship between these two, x, y. They have two variables, x and y. All right, let's see this example. A computer was recently purchased for a small business for $2,000. The business manager predicted that the computer will be used for 5 years, and the value in dollars Y in the computer in X year will be this situation. Complete the table. So it means this a brand new computer is $2,000. After 1 year, they have $300 cancel value was lost, right? So initially you pay is $2,000. After 1 year, became $1,700. After 2 years, you put a 2 inside here, you got a negative $1,400. You have 2 years, so lost $600, right? So after 3 years, you lost 900, so you got 1,100 here, right? If you got a 4, you will be 10, what? 800, right? If you 5 years later, is only $500 value left. So you can graph in this one. So X is became the years, Y became the monies of the value of the computer. So you can build the relationship between them is X, Y, right? You can become a pair. All right, so it's 0, it's 2,000. If you use 1 year, left is 1,700. If 2 year, you got 1,400. 3 year, you got 1,100. 4 year, after that, you only left 800 of value of the computer. And after 5 years, only 500 left. All right, let's read this one more time. A computer was recently purchased for a small business for $2,000. The business manager predicted the computer will be used for 5 years, and the value in the dollar of the computer in X years will be made this situation. They have relationship between the year and the value of the computer. Complete this table, so you can get this one. So actually, you got these pairs. All right. So how you graphing this one into X, Y? All right. So we can let's use this Y. Let me do this. This is 5,000. No, that's not so good. So X is means year. Y we make it a little bit reasonable. This say 1,000. Okay, this is 2,000, 3,000, 4,000, 5,000. So when first year 2,000, so it's right this dot. 1 year, I'm sorry, 0 year 2,000 is right here. When 1 year 1,700 is right this dot, and the 2 year 1,400 is right this dot. All right, 3rd year only 11. So you can mark here, say 0, 2,000. Here is 1 is 1,700. Definitely you can mark it on. And 4th, you got 8. 3 is 11, should be over a little bit over 1 here, right? And here 4 should be right here. And 5, you got 500 left. So you can see this dot. We can link these all dots together. Would be like this. Like this. So the relationship of the computer value to the years is this kind of linear line. We can graphing like this linear line. So after how many years this computer value will be 0? The question would be, how many years the computer 0 will be 0? When it became 0? When this became 0? This is what the year. So we can put this 0 back here, Y, right? So you can go to X. So actually you can get 0 equal negative 3X plus 2,000. So X actually equal what? 2,000 over 300. So you got a 6.67 years. So after 6.67 years, the computer will be totally lost its value. So actually it means 6.67 actually should be right here, and y became 0. Actually it's this dot. And when it initially is 0 year, your initial computer value will be $2,000. So you can use the linear line describe this situation, the value growing station. So actually you can see this one goes down, is the slope in this way. Earlier when graphing this one close like this way, right? When we're graphing y equal 2x like this one. So you can see this is somewhat slope happening, right? This is another slope, and this slope is to the left, and this slope to the right situation. So this is actually the linear line. Linear line is straight line. It's a straight line. And they have the linear relationship between the x and y. Let's see some more examples. All right. See some more examples. All right. So suppose say they have x, y, they have a linear relationship between the two, and their relationship is like this: x minus 2y equals 6. X minus 2y equals 6. So how we do this one? So we can use the xy table methods. All right. So when x equals 0, y equal what? -3, right? When x equal 1, suppose say x equal 2, easy to calculation. X equals 2, y equal -2, right? You can do that. So L2 minus 2y equals 6, right? So you can get a y equal -2, right? So you can use this basic equation to get solutions. Actually, with multi-solutions, we need to find out. And what about when x equal 4, y equal -1, right? So you can get this one. You can get it out there. So let's graph this one into this way. All right. So x equal 0, y equal -3. X 0, -3 is right this dot. Right here is 0, -3, and 2, -2. When the 2, x equal 2, y equal -2 is right here. When x equal 4, y equal -1 is right here. So actually dot, these three dot. So we can use the graphing, graph them together here. All right. Like this way. Right? We can graph it out. We can graph this line. We can graph this line. We can graph this one right here. So here is x minus 2y equals 6. Of course, we can do some proper transform it. All right, let's transform it. X equal minus here, x minus 2y equals 6. So we can move the x to the right. Right, move x to the right, and both sides divided -2. Right, so okay, we write like this way: half x minus 3. All right, we can do this one. So actually linear line also can describe half x minus 3. So we can check it. When x equals 0, y equal -3. Yes, right? When x equals 2, y equal -2. 2, -2. When x equal 4, here became -1, right? We can check it. So here is 0, -3. Yeah, we can check it, find out, right? We can find out. So when we know why it became 0. So when y became 0, x equal what? 6. Should be 6. This one should be 6, 0. Right? So you can find 6, 0. Here, this is y-intercept. This is x-intercept. called X-intercept. This is Y-intercept. They cross the Y, actually called Y-intercept. All right. So let's on slope here, right? So we'll talk this a little bit later. Let's slope. Slope. What the slope means? Means here every X increase 1 unit, what happened to the Y? So you can see here, let's move 2 units to the right, Y increasing 1 unit. This X increasing 2 units here, right? Y increasing 1 unit. So the slope here is 1, here is 2. The slope is the Y part, increasing part, divided X increasing part. So slope called half, 1/2, called half. Actually, exactly is this part we call slope. Slope, just like when X increasing 1 unit, how much Y change? You can see X increase 1 unit, Y increasing half unit. The slope is half. So in this description, we give there a description, say Y equal half X minus 3. So you can see the slope here is half. Slope, we'll say S. And the Y-intercept is 0, 3. So when X equals 0, Y equal what? We call Y-intercept. Y-intercept means X equals 0. Y equal -3. So X-intercept is Y equals 0. X equal what? 6. See, you have 6 here. So slope, Y-intercept, X-intercept. Right? We can quickly determine the based to these kinds of linear line. So this is the slope. Sometimes use the M, sometimes use the S. And this is the Y-intercept. You can see X equals 0 here. X equals 0. Y is exactly equal this part. All right. Okay. So we have the slope, Y-intercept, X-intercept can determine this linear line. Right? This linear line. Let me save this one quickly. And let's do one more example before we end. Now let's graph in this one. All right. So you can see here is 2x plus y equal 5. We do some transformation. Y equal -2x plus 5, right? Right. So we can do right here. We do the x, y tables. All right. So here is x, here is y. When x equals 0, y equal 5. Actually, this is a y-intercept. That's what I was saying, right? When x equal 1, y equal -3. You can put x replaced by 1. So here get -2 plus 5. So you got a +3. So here is 1, 3. We just need 2 points. Actually, we just need 2 points. We can find a value. Of course, you can say when y equals 0, what to find at y? Well, y equals 0, x equal what? 2.5, right? 2.5. So actually it's 2.50. All right, so let's put the 3 dots on this xy coordinate system. XY coordinates. This x is from -infinity to +infinity. Y is -infinity to +infinity, vertical way. So x is 0, 5 is right here. 1, 3 is right here. 0, 5 is 1, 3. And 2.50 is right here. 2.50. All right, so you can graph this one. So you can graph this linear line. Oh, I need to adjust a little bit. Okay. Like this. All right. You can graph in this one like this. So actually, you can see this one. You can see what's happening. So this is y equal -2x plus 5. What's the x-intercept? X-intercept is right this point, right? Because when they cross this x axis, Y-intercept is this one. Y-intercept is x equals 0, 0, 5. This is x-intercept. Say, all right, so what's the slope? What's the slope? Slope, what are we talking about? What we're talking about is when x increase 1 unit. Let's give this one from, suppose this here. When x increase 1 unit, actually move to 1 unit to the right, right? X increasing from 1 to 2. What is y happening? Y happening from here is 3, right? 0, 1, 3 goes to what? Goes this 2, 1. Actually, y decrease 2 unit. X increase 1 unit, y what happened? Decrease 2 unit. So use this y change part over this 1. So the slope will be -2 over 1, right? So became -2. Became -2. So -2 actually exactly is coefficient in front of this x. All right. So this is slope. We can so if you describe y like mx plus b, we can this kind of go into general description. Linear line. So this will be slope. The coefficient in front of x, the coefficient in front of 1 should be 1 first, and then you first, and this kind of coefficient we can consider is the slope. And this is when x equals 0, y equals b, right? So this is y-intercept. Y-intercept. All right. So x-intercept, just you needed to make the y became 0. X-intercept is what? Y became 0. X-intercept is -b over m, right? B, -b divided m. So this became x-intercept. So actually, I tried to give more examples of the similar way, all right, to judge the slope to x-intercept and y-intercept. So please use this one to graphing. So today's homework will be how to graph linear line, use the XY table to find out the x-intercept, y-intercept, and slope. Actually, you can see here, there's some description in my small example. Actually, I try to do, but not necessarily mentioned here, but I want to mention a little bit more. So like this one, xy, here, the xy, these all are linear shape, linear line. You can do this one. Try to graphing x, y, y equal to, how you graphing this one. I will talk this a little bit more next class. Something like this situation, they have a square. They will be not linear line. We will talk a little bit more later. This is non-linear line. Currently, if they are linear line, the relationship should be like this. Or we can say we move x to y to the one side, ax plus by equals c. If you move all x, y, can describe it into like this called standard. This is called standard format. This is called slope y-intercept format. Right? So you can read the slope here. You can read the y-intercept here. This is called slope y-intercept format. This is called standard format. You can see, my point is, you can see here the degree of here is 1. The degree here is 1. All right, the degree here is 1. And it's nothing else, only 1. They can show is the linear line, straight line. If they have different degree, that something like here is a different 2, they are not linear line. All right, excuse me. All right, so I will send some homework a little bit later to you guys about how to graph linear line, to find their x-intercept, find their y-intercept, and slope. Sounds good? All right, that's all for today. That's all for today. Any questions? No, I didn't hear anyone says any questions. So see you next week. Have a wonderful weekend. Bye-bye.
Thank you. Bye.
Bye-bye.